So today we will continue with mathematical operations with complex numbers. Specifically, today we will see division with complex numbers. Remember something we saw in the past? It's common to rationalize roots from the denominator. So what happens here? Remember that the letter I comes from the root of -1. So if we have letters I on the denominator, it's like having a root on the denominator. That's why it says we cannot have I on the denominator. So what happens if I have I on the denominator? We need to rationalize it. So how's the process for doing a division with complex numbers? First of all, we need to transform our letters C to have powers of I. Then, if it's possible, we need to do the division. This one, it will be only possible with monomials, because if we have polynomials, it won't be possible. But if we are able to do the division, we need to make it. After doing the division, if it's possible, if it's not possible, that will be the second step. We need to rationalize the denominator because we will have i's on the denominator. And after rationalizing the I, we will be able to do like term simplification and ordering of the answer. So it's not very difficult, but let's see how to do it. Imagine in exercise 1 we have C1 and C2, and it says do the division between C1 and C2. First of all, we need to transform them in order to have powers of I. So it's going to be C1 equals 5 that multiplies the square root of 36. It's 6i. So in this case, C1, it's going to be 30i. C2, it's going to be minus 8i. It says we need to do the division between C1, that it's 30i, divided by minus 8i. In this case, we don't need to do the rationalization. Why? Because I divided by I, we can eliminate them. We will have only plus divided by minus. It's going to be minus 30 over 8. We can simplify our fraction, and it's going to be minus 15 quarters. So in this specific example, example number 1, we don't need to rationalize it. Why? Because I divided by I, they can disappear, and we will have only real numbers. But let's see other examples when we have I on the denominator part, and we need to rationalize that denominator. So in this second exercise, we have C11 and C8, and it says do C11 divided by C8. So first, we need to transform them to I. So C11 is going to be 10 minus the square root of 4, it's 2i. In this case, it's going to be C to the 8, that it's going to be minus the square root of 36, it's 6i. So in this case, it says C11, it's 10 minus 2i, all of it divided by minus 6i. So of course in this case we cannot like cross the I with the I because we have addition and subtraction on the top. We have a binomial divided by a monomial, so in this case we cannot eliminate the I. So what we need to do here, we need to rationalize it, but first maybe we can simplify. Why maybe we can simplify? First of course, maybe we can put the minus on the outside part. It's going to be 6i on the bottom part. But maybe on top we can take out a 2 that multiplies 5 minus I. If we do it that way, we can simplify it because 6 and 2 can get simplified. And it's going to be 3i, 5 minus I. We can divide by 2. What happens next in this case? In this case, of course, maybe we can multiply by something in order to rationalize. So what do we need to do in this case? We need to get rid of the I on the denominator. What possibilities we have? If we transform the I to I squared, it will become a minus 1. And of course, we will be able to eliminate the I. So in this case, in order to rationalize, we can multiply by I on the denominator and by I on the numerator. What will happen on the denominator? On the denominator, it will happen that I will have 3i squared, and then it will be possible to change the I squared for a number, and in that case, we are going to eliminate the i's from the denominator. So what will happen on top? On top, it will be 5 minus I that multiplies I. So in this case, it's going to be minus 3 that multiplies minus 1, and it's going to be 5i minus I squared. This minus 1, we can change it to a plus, all of it divided by 3, and it's going to be 5i minus I squared. We can change it to minus 1. So our final answer is going to be 5i plus 1, all of it divided by 3. And remember, the correct order is first the real number 1 plus 5i, all of it divided by 3. And that will be my final answer. So let's check again what do we need to do in this case. We have I on the denominator. So we cannot have I on the denominator because having an I, it's like having a root. How do we eliminate the I? If we convert it to I squared, we can change it to a minus 1 and the I will disappear. So in this case, 3i to have I squared, it needs to multiply by I. But if I multiply the denominator, I also multiply the numerator by I. In that way, it will be I squared on the bottom, and we will be able to eliminate the i's from the denominator. So the important part actually on division is doing the rationalization of the I. If we have only I, a monomial, we will need to multiply only by I to complete the I squared and take it out. In the next exercise, exercise number 3, in order to take out the i's, we will need the product of the sum and difference because we will have a binomial on the denominator. So let's see another example. So in this case, it's going to be something very similar. First, we need to transform them to have i's. So it's going to be C1 5 minus 2i, and C7, it's going to be minus 1 plus 2i. If we put the division, C1, it's 5 minus 2i, all of it divided by minus 1 plus 2i. What happens here? Of course, we cannot cross the I with the I because we have polynomials on top and also a polynomial on the bottom part. So remember how to rationalize when we have a binomial. We saw it in the last videos. If we have a binomial, we need to multiply by the product of the sum and difference of that binomial in order to be possible to rationalize. So it says that the product of the sum and difference is going to be one that do not change sign and the other one that change sign. Of course, maybe somebody can use the signs like they don't change the sign of the 2 and they change the sign of the 1. Both possibilities are correct. So in this case, I use it in this way because it's the order they are presenting it. The minus 1 doesn't change. The plus 2 change of sign. The one that I put on the denominator, I need to put it also on the numerator part. So what will happen here? Of course, in the denominator, it will be the product of the sum and difference. The product of the sum and difference says the one that do not change sign squared minus the one that changes sign squared. So what will happen on top? On top is going to be a binomial times a binomial multiplication. So it's going to be, let's see, on the bottom part it's going to be minus 1 squared, it's 1 positive, minus 4i squared that is going to be 2i, that is going to be squared, it's going to be 2 squared is 4, I squared is going to be I squared, and on the top it's going to be minus 5 minus 10i, minus multiplied by minus, it's plus 2i plus 4i squared. After that, we are possible to change the powers of I. So those that are I squared, we can change them. So it's going to be 10i plus 2i plus 4 that multiplies minus 1. Remember, I squared is minus 1. On the bottom part is going to be minus 4 that multiplies I squared, that it's minus 1. So it's going to be minus 5 minus 10i plus 2i minus 4, all of it divided by 1 minus times minus, it's plus 4. That means our final answer on the denominator 4 and 1, it's going to be 5. On the numerator part, first the real numbers is going to be minus 9. Then the imaginary numbers, minus 10 plus 2, it's going to be minus 8. Minus 8i. And that will be my final answer. So as I was telling you, in the division, the important part is we need to rationalize the denominator, and we have two possibilities. In exercise number 3, we saw when we have only I, a monomial on the bottom, that we only need to multiply by I to become I squared and eliminate that I from the denominator. And in the case we have a binomial on the denominator, we need to multiply by the product of the sum and difference, because the product of the sum and difference will give us one real number, one I that has an I squared, that it will be changed to a real number, and that way in the final answer we don't have i's on the denominator. So let's see one last example. So let's see, in this exercise it's going to be almost very similar to exercise 4. First thing we need to do, we need to transform the c's to have i's. So this one is going to be 13 plus 2 that multiplies the square root of 36, it's 6i. So it's going to be C13, going to be 13 plus 12i. And the other one is going to be C9, it's going to be equals 8 minus 6 that multiplies the square root of 16, that is going to be 4i. So C to the 13, it's going to be 8 minus 6 times 4, it's 24i. So in this case, it's going to be C to the 13, it's 13 plus 12i. All of it divided by 8 minus 24i. What happens here? Remember, we need to check how we rationalize the denominator. In this case, we have a binomial on the denominators. We need the product of the sum and difference of that binomial in order to be possible to rationalize it. So what will happen here? On the denominator, it's going to be the one that do not change sign, squared, minus the one that changes sign, squared. What happens on top? It's going to be a normal binomial times a binomial multiplication, and it's going to be something like this. So what's going to happen next? 8 squared is going to be 64 minus 24i, all of it squared. 24 squared is going to be 576. 576 I squared. What will happen on top? Of course, it's going to be a multiplication of two binomials. So it's going to be 8 times 13. It's going to be 104 plus, then it's going to be 13 times 24, that it's going to be 312i. Then it's going to be plus 12 times 8. 12 times 8 is going to be 96i. And finally, 24 times 12, it's going to be 288 I squared. So the next thing we can do is we can change the powers of I. So it's going to be 104 plus 312I plus 96I minus, or well, let's do it in two steps, 288 that multiplies minus 1, and on the bottom part is going to be 64 minus 576 that multiplies minus 1. So it's going to be 104 plus 312I plus 96I minus 288, and on the bottom part it's going to be 64 plus 576. So what will happen here? On the bottom part is going to be 576 plus 64. It's going to be 640. Then remember first the real numbers. So minus 288 plus 104, it's going to be minus 184. And in this case, 312 plus 96, it's going to be plus 408I. This will be our final answer, but we can simplify it. Let's do it here on the left. This one we can simplify it. If we divide by 2, it's going to be minus 92 plus 408 is going to be 204I, and the one on the bottom it's going to be 320. We can divide again by 2. If we divide again by 2, it's going to be minus 46 plus 102I, all of it divided by 160. And again, maybe we can divide by 2, and it's going to be minus 23 plus 51I, all of it divided by 80. And we have finished simplifying our answer. So the idea is basically the same on any exercises. In the case of division, what we need to do is we need to eliminate the i's on the denominator by rationalization and simplification of the answer. So that will be today's topic, that was complex number division. See you on the next video.